and welcome to a new video of the ongoing series of physics lectures. So here in this lecture, as promised in the last one, we are going to solve some questions related to the dimensions. How can you find the dimensions, and what we need to do in order to find the dimension of specific physical quantities. We are going to see them, we are going to solve them, and we are going to also apprehend the formulas which we need to learn, or which are needed to be learned in order to solve these dimensions. I don't think so there are much formulas, but you will have to learn the formulas related to the physical quantities. So let us begin. So our very first question would be to find the dimension of acceleration. See, acceleration is nothing but the speed by which a body is moving. So what we'll call acceleration, first of all we'll write the formula of acceleration, which is change in velocity upon time, means how much velocity is being changed in a specific given time. So first of all, how we'll write it is dimension of acceleration. In the last lecture I told you that in order to find the dimension, we write the physical quantity in a bracket. So dimension of acceleration is change in velocity is nothing but velocity. So dimension of velocity upon dimension of time. Velocity, in the last lecture we had found that it is m0 l1 t minus 1. Now you will ask that why I haven't written m0 over here. See, since the m is 0, there's no need to write it. In later part of also of the video, if we are going to use velocity, we won't write m0, as m raised to 0 is nothing but 0, and there's no need to write a 0. So we'll just write L1 and t raised to minus 1. I had also explained you that how this t became t raised to minus 1 upon time is nothing but t raised to 1. So now let us see the next part of the question. So now here what we have is that t1 comes up from since in the last few seconds you would have saw that it was L1 t minus 1 upon t1. So when that t1 came up, it became t minus 1, and since already t was present here, so we just wrote it minus 1. So what will it become? Dimension of acceleration is L1 t minus 2, as minus 1 and minus 1 is minus 2. We will not multiply them, we'll just add them. Now second, we have to find the dimension of force. Now let us see. Force is mass into acceleration. So we will since we have to find the dimension of force, we will write for dimension of force is dimension of mass into dimension of acceleration. So dimension of mass is nothing but m1, and dimension of accelerations, we had just found that it is L1 t raised to minus 2. So we'll write here L1 t raised to minus 2. So what will be the dimension of force? M1 L1 t raised to minus 2. So and now I would like to tell you something, that two different physical quantities may have same dimensions. See, it is possible that two different physical quantities can possess the same dimension. See, for example, but there's one condition, that the two different quantities should be physical quantities and nothing other. So now we'll see the examples of work and energy. So here we have the two columns dedicated, one dedicated to work and second one to the energy. So here in the work section, we have work equals to force into S, and here S is nothing but displacement. So now we have already found the value of F, which is force, which is m1 L1 t minus 2. So we just wrote it down, and since the displacement is nothing but length, so we'll write it as L1. So now we'll add them, which will be m1 L1 plus 1, it will be L2 and t minus 2. Now next one, we have energy. So dimension of energy equals to mgh. We can take either potential energy or kinetic energy, their answer would be the same. So here I have taken mgh, which is nothing but potential energy. See, I would recommend you to take total energy. If we add kinetic energy and potential energy, then also we get the formula mgh. Hence I have taken mgh here. There was a bit correction. So now m is nothing but mass, so we took m1. G, which is nothing but small g, is nothing but acceleration due to gravity, and h is nothing but height. So now what we'll take, in the place of m, mass, so we took m1. G, acceleration due to gravity, which is nothing but acceleration. So as we had found the value of acceleration, so we'll write L1 t minus 2. And h, height, so we'll write it as length L1. So, and we'll add them. So what it will be, m1, L1 plus L1 equals to L2, and t minus 2 as it is. So what you saw is that work and energy can possess same dimensions, but the only condition is that they should be, both of them should be physical quantities and not any other quantity. So now here we have a note with us which says that first one, it is divided into mainly 4 parts. So first one is mathematical constants are dimensionless. See, for example, in we have 1 upon 2, which is half. So if we are going to find their dimension, we'll get m0 l0 t0, as neither it possesses mass, not length, and not times. So it will be dimensionless. And pi, it is also 22 upon 7, so m0 l0 t0. So what we'll get is dimension 1. Therefore mathematical constants are dimensionless. Now next one what we have is that all the trigonometric functions are also dimensionless. See, sine can possess dimension, cos, tan, cot, sec, cosec, they can possess dimensions, but the theta attached to them does not possess any dimensions, and that theta only makes whole of the sine theta, cos theta, tan theta, cot theta, sec theta, and cosec theta dimensionless. Next one is exponential functions. Exponential function you would have learnt in trigonometry, and which I had taught in the maths wala series. In that I had told you that e2, e minus 2, ex2, ex, they are available, and e means exponential function, but this raised to number which is given, it is dimensionless, means e can have dimension, but the raised to number makes it also dimensionless. Now the last one which we have is log. See, log can have anything. We had learnt logarithm in the mathematics series logarithm lesson. So what we saw there, that log can have any number, log 10 to the base 2, log 18 to the base 3. We can have there can be any number, but log can possess dimension, but the number which gets attached to it is dimensionless, which makes this whole equation dimensionless. So that's all for today, guys. We learned we took many examples of acceleration, force. We also understood that how can two physical quantities possess the same dimension, and we also saw these some notes which should be noted while solving the dimensions. Hope you got to know something. In the coming parts of physics lectures, I'll teach you some different formulas, some different questions related to alpha and beta, and also these lessons. So stay tuned, guys, and thanks for watching, and bye bye.